Thank you. Good evening to all of you. First of all, really apologize for the Monday. It is due to the Minitab server or Minitab issue, and they fixed yesterday. Now you will have the Minitab. I think you can use also Minitab 23. So let's start multiple regression. Yes, you have a question. Okay, so let me share the screen. Okay, hopefully you can see my screen now. So multiple regression, let me give you basic points. So if you draw a graph between two variables, y and x, and let's say this is the line coming, there are many points. If you use like these are different points, and if you put a aggregated line or best fit line of these points, so in this line, this is called intercept. From here to here, this is called intercept. And we need to get the slope. So slope is you just mark 2 points anywhere on the line, draw perpendicular and horizontal lines. And this difference in del y, and this difference in x. So slope equal to del y by del x. And this is intercept. So the equation of this line would be y equal to intercept plus slope x. Okay, so this is the intercept. Usually we call it a plus b x. And this is nothing but a straight line equation. So you know what is a. If you know a, which is intercept, if you know the slope and you put the value of x, you will get the value of y. So y is called dependent variable and x is called independent variable. So this is in the case of you have only one variable is dependent and you have one variable independent. This is called simple regression. Now we are going beyond this where you have y equal to a plus bx1 plus cx2 plus dx3 and so on and so forth. Where y is dependent variable and these are independent variable. So y result of outcome depends on many input variables. So this is what is multiple regression. We are going to look into the calculation and other things. Okay. So hope you understand what we are going to look into this. So here I have this real data. If you look into this data, and if you know that if somebody wants to come to United States for pursuing higher education, they need to have following eligibility, like they have to have GRE or GMAT, English score, what kind of university they would like to apply, like 4-star, 3-star, 5-star, all these one to five ranking university. They need to write a statement of purpose, which is a letter why they want to do this program. Letter of recommendation, which is, you know, ex professors or colleague or, boss or supervisor, they can write letter of recommendation, and the GPA in the previous degree. So GPA. In India, we have a 10-point score. Like here, we have 4-point GPA, but in India, they consider 10 point. Now here you have binary thing, which is research university or teaching university. So zero is only teaching university, one is research university, like Eastern is only teaching university. And so, and here is the chance of admission. So this is a bivariable. Chance of admission depends on this x1, x2, x3, x4, x5, x6, and x7. So y, the equation would be y a plus bx1 plus cx2. Keep going all. E, F, G, E, F, G, H, H, x7. E, F, oh, sorry, G, H. So now, now we would like to know the values of A, B, C. So we are going to look into this. So now what we need to do, I just go, we are using only one best fit method, and we go under statistics. We have and regression, and we have fit regression model. We are only going to use this one. Okay. When you run the regression model, you can do the prediction. So first step to what is the variable? Response variable is chance of admission. And I just put from here to here all continuous, though I can put some here categorical, but it will be little different. So let's understand this way. Chance of admission and this, and we have different options here. I'm not touching anyone. I'm just going to do this. Now you have this equation, y equal to a plus bx1 plus cx2, uh, or all the way here, gh. So here instead of x1, x2, x3, x4, they have right here the values, sorry, name of the variable. Now I would like to check whether this my regression is valid or not. So there is a null hypothesis and alternative hypothesis in this, and null hypothesis H0 says, remember, H0 says all constants are are zero. Sorry, please, zero. And alternative says at least one constant is not zero. What is the meaning in simple word? This is useless. If these all constant are zero, means this is zero, 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 and this is zero. What is the meaning? Whatever value you will give, chance of admission will be zero. So it is called useless. Now look to useful. At least one is not zero. Means if any variable or any constant is not zero, whatever value you will put, you will get some results or you will get some dependent variable value, isn't it? So this is null hypothesis and alternative hypothesis. Now let's check, this hypothesis. So now based on that, my previous course and you have attended that. Tell me. So here we have all these, and let me make it bigger. Can you see this screen? Now you tell me these are the p values. This is constant. This is intercept. This is slope of GRE, slope of TOFEF, EFL, slope of inversity. These are different constant. This is T value. This is this value. This is this value. And this is P value. So what is this and this and this? So if you remember from 503 or those who are directly into this course, they must have previous knowledge how we can do this plus this. So basically this multiplied with this becomes this. How I'm going to demonstrate. So if you know any two values, you can do the third value. Okay, right here. Okay. So 0.104 into my 12.23. What we are getting 1.27. This is. So if you know any of those two values, you can calculate the third value because this is very simple. Standard error of coefficient and t value. This will become coefficient. So if you know either two of them, you can calculate the third one. Okay, so this is p value. Now this is a p value. And you are going to tell me, is constant useful or useless in this equation, in this result, or in this table? Yeah, I get. Yeah, thanks, Padi. Yeah, you are correct. And you know what is the rule of thumb that I also told you in the last class? What is the rule of thumb? Remember? Okay, I can tell you again. If p value is less than alpha value, this is useful. If p value is greater than alpha value, useless. And this condition, this condition, by default, we are running alpha equal to 0.05. So this is 5% level of significance we are using. We are using by default. We have not changed or we have not selected the confidence level or by default, whatever coming. And by default, this is 5%. Okay. Now tell me, Padi, you gave me this is useful. Okay, I can say this is useful because this condition is fulfilled. What about this? GRE score is useful or useless? Useful, very good.
Use,
So this is also. What about the TOEFL?
useful,
Very good. Yeah, this is correct means useful. University rating,
useless,
perfect. This is useless. Statement of purpose.
Really useless.
Perfect. Letter of recommendation.
The rest are useful.
Yeah, rest are used. Perfect. Thank you so much. And now you know what is the reason. You can see these p-values and use this rule of thumb that we learned in the previous also hypothesis testing and this. So all p-values is less than alpha is useful. So here Hadi said these two are useless because you can see because p-value is more than 5%. Here you can see more than 5%. Therefore, these two are useless. Okay. So what about our null hypothesis and alternative hypothesis in that we framed? Null hypothesis is all the constants are zero. Alternative says at least one is not zero. So what is correct? We reject null hypothesis and we accept alternative hypothesis, which is at least. So this uh, equation is good to go for prediction. We can use this for prediction. Now let's look into further. Overall regression, if I ask what about overall regression is useful or not, exactly the same thing. This is your overall regression. And this is useful. Your regression model is useful. Okay. Now, now I'm going to tell about if these are useful and useless, how we can interpret these and how we can see whether really useful or really useless. I will demonstrate later on. Okay. Now we go here. Now this is what? This is standardized error. This is R square. This is very important. What is the meaning of adjusted R square? R square and adjusted R square. R square is 82.9. So basically R square value is 0 to 1. R square is, so basically this would be written like 0.8219. R square value will be this technically. But here they are giving in terms of percentage. That's fine to interpret. So 82% change in admission, chance of admission is explained by all these variables. So 82% chance of admission depends on these, all these 6, 7 variables. So 82% chance of admission depends, other 18% will be something different criteria, but 82%, which is very high, means 80% chance of admission is decided by all these LOR, university rating, TOEFL, GRE research and all. That's good. You have 82% predictability. So change, this is R square. This is very important. 82% is considered very good. What is this adjusted R square? Adjusted R square is always smaller than R square because, you can say this is more filtered value, isn't it? More filtered value means if you are doing something, you are filtering, you remove impurities. The same thing here, if you have some data which is, some unusual observation, uh, some unusual data points or something, that those are removed. So these are the observation number 10 and all these are called unusual observation. So it you can say adjusted R square is more precise, more filtered value, which is always smaller than R square. R square to be honest, I haven't seen anywhere that is being used, but that is further, smaller value as compared to adjusted R square. So basically, R square, adjusted R square, and these things are important to know. Now look into, so let me, so this is now look into, so basically this is nothing but the same thing, p value. I'm going to explain this VIF, which is called variance inflation factor. Now look into this. So basically, in the data, when they are running the regression, these observation or these entries, data entries or data points are unusual, which is not fitting in the trend. And so what is the role of the data analyst? To look into these numbers again, ask them again whether any error or something, or you can remove also from your modeling. So these are the unusual observation which is not fitting or which is giving lot of uh, different 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 or much error from the fit line. So basically, what is the fit line? If you look into this, so this is, let's say this is a fit line and this is the observation. So this is the observation. This is here, it is much wider. If something is like here, this is the distance. So basically these observations are much away from this fit line. Maybe somebody is having 100 out of 100 in GRE, but chance of admission are very less. So, so this is about regression output. Now let's look into, I said these two variable, university rating and state, are useless. Let me prove that. So I go under, yeah, statistics. Sorry, I have there the same regression and regression. And now you can see earlier we were not having this option predict. Now once you run this model, you train the machine, and now you can see the predict option. And now you have the prediction option. So let's do two things. You select two students. They have exactly the same numbers, same score, except university rating. They have 5 out of 5, and one student has 1. One is having maximum, one is minimum. Statement of purpose, somebody is having, I think the scale is 5. Somebody, this person is having 5, and this is 1. So I can put exact GRE score. What is the range of GRE score? Let me see somewhere. So GRE score in 320s, I can take 320, 110. Let's see other things. Okay, so let me put, so GRE is 320. Let's say exact TOEFL score is 120, 110. Let's say 110 means exact two students which have exact same score in everything except one is having full score, one is having least score, and we want to see how much impact of this, highest and lowest is causing in his or her admission. Letter of recommendation, let's say 4, 4. GPA is 9.2, 9.2. Research, both are in research university. I think I put all the things, and let me do the OK. So the person who has, this is a chance of admission score, and these highest is, university rating state, somebody has done excellent job in writing, university and statement of purpose, and his chance of admission is 84%. Chance of admission is 84%. When somebody has not considered university rating, statement of just wrote anything, and his chance is about 81%. So means if somebody can do no work, no hard work, and put the statement of purpose in this, the admission will not be much affected or much. Therefore, these are 81% and 3% only. So they are not playing. One is highest, one is lowest, isn't it? So these two variables are not predicting. And there you can see this is a confidence interval, this is a prediction interval. And now what I need to, so this is regression. And now in regression, there are many other hypotheses related to variance inflation factor. What is variance inflation factor? This is the one. And this is very important to understand. Multicollinearity is observed. What is multicollinearity? Means the high correlation among variable, among independent variable. So let's say TOEFL and university rating and also let me run a simple correlation and show you. So basically our data, our BIF is okay. Up to 2 is fine because we have, so let me show you the statistics, basic statistics. And here we have, sorry, correlation. Correlation, okay. And now I take all of them together and we can score correlation by 95% results pairwise, and I can do this. So this is the, correlation, relationship among variables, and these are, cross tables, so GRE, TOEFL, and this is relationship among them. Now you can see all the relationship among them, which is highest. You can see, I can see this is 8.26 is the highest, or 8.882, which is again GPA and chance of admission, which is 88%. What else? I think this is the highest. So look into that p-value. Are these correlation are useful? Yes, these all correlation are useful. These all core. So if suppose two variables are showing exactly the same relationship, or three are having they have very high GPA, very high GRE, they have high collinearity, they have high multicollinearity, and that results into multicollinearity, and which is a cause of concern, because why we are having three variables when they all are showing the same behavior? So here, so this is the interpretation, and I am just going to show you the VIF. So here, if you can you see my slides? If VIF is one, no variance inflation. If two, mild is okay. If it is more than 10, then strong variance inflation. So basically, in research, in real life, up to 4, 5 researcher consider, because mild to little bit, so up to 4, 5 is considered, but 10, 7, 8, 10 is not considered. So what you need to keep here, this you need to check. And then if you see where you see then you need to check so what is our BIF? 1, 4, nothing is going more than 5. So we don't observe multicollinearity. We can simply say. Means all variables are not highly correlated. And then there are other things. So I shared everything right here. Just a minute. So this is you will see this at the end of the module, and I can all the things are right here. You can clearly check everything. So this is regression analysis. Are error normally distributed? We can also use, but I think we have not given any example or any question for that. So everything I have clearly clearly made in this PDF or wrote clearly. So you can go ahead and you can refer this PDF, and this is right at the end. One more option is there. I don't know, but because I never tried in this. Here we have help. I don't know, but here if you look into this application, here we have assistant. You can see assistance, and under assistance you have all the options where you can regression, and then you can choose which one multiple regression. You can see the response variable, chance of admission, but here you can't keep more than 5 variables. So if you want to keep 5 variables, because I'm doing 7, it will not take. So I have to do GRE score, TOEFL, and research, and then I can do. So it has limitation up to 5 variables, but it will give the. I remove those two, and it will give you the this kind of output that you need to interpret. And so this is another way of doing. So this is multiple regression, and right here, okay, just a minute. You have this PDF right at the bottom, module 3. Where is, yeah, this is the one. This is the file that gives you a Minitab handout to do multiple regression. So this is what I wanted to explain. And it could not be explained without Minitab. You can do all these things in Excel also. However, it's easy to understand and interpret in Minitab, and it's a just click process here. Any question? Yeah, one question. Yeah, I would like to answer related to discussion that most of you are asking. So let's say understand this. When we are when we are having the data, we cannot take one is like uh, NVIDIA, and one is like uh, local company or local organization. So basically, when you see the data, when you look into the example, I shared some book examples also, book data also at the end of the module. You can download those zip, understand the data. If you have consistent data, like here you can see this is the student's data and this is the real data, then you can have better model. But if you say one student is scoring one GRE score and other student is 330, that kind of numbers, if you have very high number, very low number, certainly model will not be good and it will not be a valid model. Therefore, whatever we are doing, we must make our assumption that what is the range, what is the limit that we are going to have the data. So if suppose 500,000 or 5,000 employees are laid off, and one place only three employees are laid off, and one place 600, so certainly 5,000 versus three employee versus seven employee versus, that is not good design of the experiment. When you design the experiment, you need to understand what we are going to do. So having the data consistent and in the same range will make your model valid, will make your model. Otherwise, you will get the model which is not valid. I don't mind whatever you are getting. The reason your process must be good, you should follow exact steps. And if data is not supporting, no problem. If data is not supporting, that's fine, because you learn the process when you have the real data in future, and you will be able to carry out that experiment. So any question, please feel free to ask. If no, have a wonderful evening, wonderful night, and I will share this in the announcement later today. And yeah, we will meet next Monday. Hopefully, we will have our Minitab working properly. Thank you. Thank you.
Have a good one.
Thank you, Fadi.